Thanks for joining us today. My name is JP Edelin.
Hello, my name's Noah.
Hi, my name is Ethan. We are Group 56, and today we are going to talk about resistance welding.
Resistance welding is the process of joining two pieces of metal into one workpiece by taking two electrodes and pinching them between two pieces of metal. And these two electrodes then have a current that's sent straight through it. And then this current superheats the metal and causes the metal to become molten at that area. Now, added with the pressure forces, once the current is cut from the actual welding process, cut from the electrodes, then the material starts to solidify and we get one workpiece as the molten material is now joined together. And this creates a strong connection between two pieces of metal, permanently creating one workpiece. The main process specifically, if we break it down, the electrodes are clamping onto the two pieces, kind of like a pinch, like they're pinching the two material. And these two plates have this little connection surface called the lap joint. And when these electrodes send current through each other, the workpiece acts like a super resistant material, which generates a lot of heat, as you may have seen, like with electronics, like they get so hot. And this heat causes the metal to become molten. And once it becomes molten, the two workpieces basically mix together. And these two pieces of metal start to cool together and they act as one piece. And then what's left behind is the weld nugget, which is kind of like a scar in a way, to where that is the point to which a heat was drastically removed at a fast rate. And you get left with a weld nugget.
Resistance welding has a large variety of types, all based upon the original concept, but taking slightly different paths to achieve the same goal. The first and original is the most simplistic, spot welding, where two electrodes pass current through two pressured parts. The combination of pressure and current creates a small area in which the two parts are now welded, called a spot weld. The next common variety of resistance welding is seam welding. The major change is that the electrodes are formed into wheels and roll the material between them. This way, a continuous weld is developed across a longer strip. This specific weld is what is often utilized in fuel tanks, boilers, and pipes, since there's an entire edge that needs to be mated together. Another version of resistance welding is flash welding. This case removes the electrodes entirely and simply opts to run the current throughout the two parts. The resistance is created by an intentional space left between the parts such that arcs of current must jump from one part to the other. This process makes the material moldable so that when the two parts are then forced together, they stay fused together.
There are many advantages that resistance welding offers over other similar processes. Because of the nature of this process, resistance welding machines can operate at very high speeds, leading to higher rates of production. The joint formed by the weld is usually solid and reliable and is perfect for thinner sheets of metal under a 1/4 inch thick. Additionally, the process only requires the use of electricity to form the joint, meaning that no other filler metals or consumables like flux or protecting gases are necessary. As a result, resistance welding is also more environmentally friendly compared to other forms of welding, since no waste material is directly produced. However, resistance welding also has its disadvantages. This process requires a huge amount of power to be able to weld two metals together, and cannot weld metals that are more than a 1/4 inch thick, since it won't be able to reliably pass enough current through the material. Resistance welders are also enormous machines, so they are not easily portable. Furthermore, the electrode tip that passes current through the metals can wear down over time as the machine is used. The size of the machine, the power requirements, and the maintenance requirements can all contribute to a steep cost associated with resistance welding. Despite their disadvantages, however, resistance welding has become heavily relied on by many different industries in the modern age.
As an industry example, we have the spot weld machines at the Ford Motor Company's assembly plant. This one in particular is going to be building the 2020 Ford Explorer. And so as you take a look, you can see that the spot weld machines, they all come into action. They start going around, spot welding all the panels together. And there's like 6 machines per car, and the way they do this is really cool, as it's just fast production to where you can do like 8 cars at a time if you have like all these machines at once. And you'll see right here they're putting together all the body panels for 4 cars, and the spot welding machines are now spot welding all the materials together. And this is such a fast process that back in the 50s and such, when people hand spot welded them, you probably get only 1 car every 2 minutes or so. It's a lot slower process, as you're not having a full robotic army doing it. And here you can do 4 at a time. So it's a really cool example.
Aside from the automotive industry, resistance welding is used in the production of fuel tanks, boilers, and even pipes. On this image of sealed pipes, one can make out the continuous resistance weld line used to hold the once flat material into a cylindrical shape, shown in the circled area. Resistance welding provided a new way to fasten 2 parts together. While technically this could replace any method utilized prior, including screws, nuts and bolts, glue, etc., the rivet was the only fastening system to truly be replaced by resistance welding. Both options provide a permanent fixture, but by welding, the fixture is stronger and much more time efficient to produce. Resistance welding provides a highly important ability to securely mate 2 parts together in a variety of ways. While other methods such as riveting are always alternative options, nothing else provides the reliability and efficiency this method does. It is an incredibly important aspect of the automotive industry, as well as the manufacturing of many other components. With a variety of types, resistance welding is applicable to a wide variety of scenarios.
We hope that you enjoyed this video on this unique manufacturing process.